Hi everyone, in this video we're going to go through the rational root theorem. Now there's quite a bit of theory on this page, but basically what the rational root theorem is used for is when all of our solutions are not integers. So this example here, we've got this cubic, so 2x cubed minus x squared minus x minus 3. So when we're looking for integer solutions, one of the solutions should be a factor of this constant term, so -3. So we can try all those factors, so 1, -1, 3, and -3. And when we substitute all of them in, none of them are going to be a factor. So what it means here is they do not equal to 0. So when it doesn't equal to 0, there is no integer solution. All right, so you could go through and test all of them. I'll show you in this video how to do that on the calculator. It's a little bit easier. Here it's quite good because we've only got 4 that you would have to test. And when you're doing other polynomials that do have integer solutions, it's not going to be that many that you would have to do by hand. So I'm trying to articulate the point I'm trying to make. All right, so you can see that 1, -1, 3, and -3 aren't solutions. Therefore, we don't have an integer solution for this polynomial. So we've got to say, well, there must be a rational solution, or we can test whether there's a rational solution. So basically, instead of an integer, can we have a fraction? Okay, so that's what we're going to look at today. So I've highlighted down here that 3/2, which is a fraction, is actually a factor. Or not in itself a factor, but it contributes to being a to the solution. Okay, let me go to the video because they're probably going to explain it a little bit better. Now, before I do the example on the rational root theorem, I'm going to show you example 24. So here we have an example where our solutions involve integers, and then in the next example I'm going to show you, you'll see when they're not integers. So basically there's a little bit more working involved, but nothing that is beyond what you are capable of doing. All right, so let's play this.
To show that x plus 1 is a factor of this expression, what we need to do is show that if we replace x with -1, then the value of this expression will be 0. So the way to set this out formally is to call this expression here p of x. Then what I'm going to do is clearly say that I'm about to replace all of my x's with -1. Once we do get to a value of 0, it's important to restate the statement, what it is that we're trying to show. And so you can see at the bottom there, I've got therefore x plus 1 is a factor of this expression. The next part of the problem states, hence find the other linear factors. So all that means is we need to fully factorize this expression here. In order to do that, we need to use long division. So to do long division, what we're going to do is start off by saying x times what equals x cubed. So what you'll see is me doing these black circles around and around and around our expression here. So x times what is x cubed, and then we're going to write our answer, keep following the circle around, up the top there is x squared. My next step is to come back around again, the circle, and multiply x squared with this expression here. So we end up with x squared times x is x cubed, and x squared times 1 is x squared. What I'm going to do then is subtract those two equations. So I end up with x cubed minus x cubed is 0x cubed, and -4x squared minus x squared is -5x squared. The last step is to drop the next term down. Now I start my circles again. So x times what is 5x squared? The answer to that is 5x. So that gets written up the top here. My next step is to say -5x times this expression out the front. So -5x times x gives me -5x squared, and -5x times 1 gives me 5x. Again, I do a subtraction. So negative 5x squared minus negative 5x squared is 0x squared. And x, take away negative 5x, is 6x. My last step is to drop the last term down. And we go again. X times what is 6x? The answer is 6. So we follow through and we're going to write that up the top. My next step is to say 6 times this out the front, and I'm going to write that underneath. So 6 times x is 6x, and 6 times 1 is 6. Now, if you've completed this correctly, you should always end up with a 0 down the bottom because we expect there to be no remainders if x plus 1 is a factor. So what does that tell us? It tells us that this expression here can be written as x plus 1 multiplied by this quadratic up the top here. That doesn't give me the linear factors though. What I need to do is factorize this quadratic. So you can see now clearly I've got my 3 linear factors listed there. And to answer the question, what are the other linear factors? The other linear factors are x minus 3 and x minus 2. Another method that you...
All right, there is another method you can use, but we're not going to...
use once you've established...
Sorry about that. I'm just trying to find the record button. There we go, just to make sure I'm still recording. Yeah, so there, if you're interested in looking at the second method, you can. Sometimes I think if you learn too many methods, it can overcomplicate things. All right, so let's now have a look at the rational root theorem. So in that example there, all solutions were integers, okay? But now we're going to look at solutions that aren't integers. So if I go back to my textbook. All right, and I'll play example 26.
The rational root theorem is really around to help us to try and factorize expressions like this one here that may not have a linear factor. So what are we really trying to do here? We're trying to factorize this cubic. So a cubic would have 3 factors that would look like this. If we had integers sitting in these 3 positions here, they must multiply to give the constant that's sitting on the end, which means that what's sitting in these positions must be a combination of 1, -1, 5 and -5 if we're going to have integers in those positions. But first what we want to do is double check, do we have any integer solutions for this cubic p of x? And you can see that if we sub each of these values into our polynomial, you can see that none of them give us a value of 0. So what does this tell us? It tells us that these 2 numbers here cannot be integers. But the question is, could we have an integer sitting in that position there, thus giving us a rational or a fractional root? So what I'm going to do is call that unknown number there alpha. And if it is a whole number, an integer sitting in that position, which would give us a rational root, then negative alpha on 3 must be a solution. Now, in order for this to be true, in order for us to have a rational solution, then alpha must be a whole number. It must be 1, -1, 5 or -5. Now that comes from the rational root theorem. Whatever's sitting in that position must be a factor of this number sitting on the end. So what we're going to do is test each of those options. So we're going to sub 1 on 3 into our equation, -1/3 into our equation, 5/3 into our equation, and -5/3 into our equation. So after testing each one of these solutions, you would find that -5 on 3 is a solution. So what that means is we've subbed -5 on 3 into each of those values of x there, and then p of x will be equal to 0, which means that 3x plus 5 must be a factor of p of x. So if we know that this is a factor, what we can do is use long division or otherwise to factorize this cubic on the left-hand side, and that gives us this linear factor out the front and this quadratic on the right-hand side there. And then what we need to do is factorize this again, because that's what we ultimately want to be able to do. Problem is, this doesn't factorise nicely. So what that means we have to do is use completing the square. When I keep going, these first three terms will give me this perfect square here. And then the negative 1 on 2 all squared minus 1 gives me negative 5 on 4. Then I'm going to use dots to fully factorise what I have on the right-hand side there. And thus, I have fully factorised this polynomial.
All right, so you could complete the square for factorising, or you could also use the quadratic formula. All right, so I think that example is quite good. I'll just talk you through it again. So remember, we use the rational root theorem when an integer is not a solution. Okay, so you can see here on the left-hand side, she substituted in 1, -1, 5, and -5. So there's no integer solutions because none of them give you 0. So that's when you'd use the rational root theorem. So we're looking at the first factor, 3x plus alpha. So alpha being if you use one of the factors, so 1, -1, 5, or -5. So you just need to substitute that in. So negative alpha on 3 for this one, whatever that coefficient of x is. So if it was 2, it'd be negative alpha on 2. All right, so she just went ahead and tested that in the same way that she tested the integers. Now, you can do that by hand. We're going to do it on the calculator because it's a lot of work, especially with the first example that we're going to look at. All right, so we get p negative 5 on 3 equals 0. So that means 3x plus 5 is a factor. Now, to find the other factors, you've got 3x plus 5. When you divide that through, you get x squared plus x minus 1. So I'll do the division with you. In the previous example I showed you, she did do the division. Okay, and then she just completed the square to find the factors. All right, so let's look at an example together. So I did question A by hand before, and that's a lot of work. So I'm going to try to do B as well on the same page. So the test is whether I can be neat, whether, oh, clearly not, and whether the computer is going to conk out on me. All right, so the first step, we're just going to look at factorising. What we do have here, we've got no x squared term, so I'm going to have 2x as one factor, and then we're going to have other factors, so it could be 2x squared and x. It's hard to tell what we would end up with here. All right, so but we're just wanting to focus on this first term or first factor. All right, so we know that 2x plus alpha is a factor. All right, the problem is we need to work out what alpha is. In doing so, we need to look for different values of, factors of -18. So that means alpha could be just do all the factors. So we've got -18, we can have 1 and -18, -1 and 18. We can have 2 and -9, -2 and +9. We can have 3 and -6, -3 and 6. So you can see there's a lot of factors that we need to actually try, and I'm just going to do them all on the calculator. All right, so what we need to do is the value of x that we're testing is going to be negative alpha on the coefficient of x, so 2. So the first one we're going to try is p of -1 on 2. All right, so I'm just substituting in these different values of alpha, and we'll see what that equals. All right, then you can substitute in -18 on 2. Obviously that is 18 on 2, I'm well aware of that. And you can test every single one of them. Now, it's not going to take you too long to do on your calculator. All right, and I'll show you how. Let me just pause while I get the calculator up. All right, so here's my calculator. Let's just go into the main screen. Now, what you can do is, excuse me, go to your keyboard and we're going to define the function. So we're just going to go to define and we can call this function anything. I'm just going to call it f. I know in the example, in this one, I've called it p as well, but f is fine. And we're just substituting in for different values of x. So I'm just going to define this function. So 4x to the power of 3 plus 3x minus 18. So all I'm doing now is telling the calculator that I want it to remember this function. So if I'm doing f of negative a half, all right, and why didn't it close my bracket? No, sorry, don't want your bracket there. Okay, and it does it automatically for me. So negative 20 is not 0, so we want it to be 0. All right, so let's try negative 18. You don't have to type negative. All right, so we get that. And you can try all different values. So I think I can remember what the answer is. So I'm going to do, I think it's either 3 or negative 3. Let me just, all right, must be negative 3. Now the reason for leaving it as a negative and a negative will help you remember that negative 3 is your solution. All right, so I tried those two, showed you that they didn't equal 0, but p of negative, so remember it's negative alpha on 2, so negative alpha being negative 3 on 2 does equal 0. So your solution, when alpha is negative 3, we're just going to substitute it back in to here. Okay, so alpha is negative 3. So one of our factors is 2x minus 3. All right, now to find the other factors, what we need to do is divide that into our polynomial. So this is going to take a lot of space to do. So 2x minus 3 into 4x cubed. Now we don't have a x squared, but we do have to consider it when we're doing our division. Oops, got the plus. X squared, and then what? We have 3x minus 18. Sorry, I just moved everything on me. All right, let's start again. So 4x cubed plus 0x squared plus 3x minus 18. All right, so I'm going to talk you through this because I think it's good practice. So 2x into 4x cubed gives me 2x squared. Oh gosh, that's a terrible x. And then multiply that back through. We should get the same thing, 4x cubed. Then negative 3 times 2x squared is negative 6x squared. Then we subtract. All right, so that should end up as 0. And then 0x squared minus negative 6x gives you positive 6x squared. Then bring down the 3x. All right, so 2x into 6x squared gives you 3x. And then multiply that through again, so we get 6x squared. And then 3x times, I'm just thinking, did I make a mistake? I don't think so. 3x So they've got negative 9x. Oh, it's all good. I'm thinking ahead. So 3x minus negative 9x. Now I feel like I've made a mistake. No, I haven't. 12x. And then bring that 18 down. All right, and then the last one, 2x into 12x gives you 6x. And then we multiply that through, so we get 12x. Sorry, just realized I made a mistake. Let me just rub out that x there. All right, so 12x, 6 times negative 3 is negative 18. Now, basically, you do want to end up with 0 because 2x minus 3 is a factor. So if you didn't get 0, you've made a mistake somewhere along the line. All right, so that means our solution is 2x minus 3 is one factor, and then 2x squared plus 3x plus 6 is another factor. Now we do need to see if we can factorize that any further. Now it is in a quadratic form, okay? So you've got to say, well, can that be factorized? A quick check is to just use your discriminant. So remember that's b squared minus 4ac. So b being 3, so 3 squared is 9. And then we've got 4 times 2 is 8. 8 times 6, is that 48? All right, so that's going to be your discriminant is less than 0. So we can't factorize that. So when I look at factorizing that, I should leave that with y equals. Okay, our solution just stays as this. Now, if you want to check your solution, you can use solve on your calculator. So we can go solve, and I wonder if I can do f of x equals 0, comma x. All right, and there's our solution. So 3 on 2, which we got before. All right, so when we were substituting in. All right, so let's have a look at the second example. Just going to write that down. Come on. Now, I haven't done B yet, so this is going to be a good test. All right, 12x squared minus 2x plus 3. All right, so let's just write out the factors. So we've got 8x here, so I'm going to have 2x, 2x, and 2x. Okay, we don't know what these are. Now, because we're using the rational root theorem, I'm going to assume that they're not integer solutions. All right, so I only look really at the first factor, this one here. All right, so we do the working out similar to before. So 2x plus alpha is a solution. We just got to work out what alpha could be. So alpha could be anything that is a factor of 3. So it could be 1, 3, or negative 1, negative 3. All right, that's a lot less possible solutions than before, which is really good. All right, so in your calculator, remember, we're going to let p equal negative alpha. So let's do the first one on the coefficient of x, so it's 2. All right, so let's check what that is. So again, using define. All right, let's use g this time. Now, I think it's got a different x, so what I'm going to have to do is clear all variables. All right, I want to clear that. and clear everything. All right, let's start again. So f of x, all right, it's not doing what I wanted it to do, so just bear with me. All right, I've just had a little play around. I don't know how to clear it, but if we actually go to define, we probably would be able to overwrite what we did anyway. So let's just try that. Otherwise, you could be waiting a while for me to work out actually how to clear things. All right, 8x cubed minus 12x squared minus 2x plus 3. All right, so if we want f of x, okay, so it's just changed that for me, which is great. So let's do f of negative half. Now you could write just 0.5 is fine, but let's try to be consistent. Oh, isn't that awesome? The first one we tried. Okay, so that means, oops, no, I don't want to write there. All right, can I write on it now? Good. So that means alpha is equal to 1. So your factor, first factor is going to be 2x plus 1. All right, so looking at our other two factors, what we need to do is the long division like we did before. So I'm just going to put a line here. All right, so we've got 2x plus 1, and that's going into 8x cubed minus 12x squared minus 2x plus 3. All right, so 2x into 8x cubed is 4x squared. And then we're left with 8x cubed plus 4x squared. All right, so we're subtracting, so it's going to be negative 16x squared minus 2x. 2x into negative 16, negative 8x. So what is that? Negative 16x squared minus 8x. We're going to have 6x plus 3. And then we're going to have 2 into 6x is 3. So 6x plus 3. All right, so, and that will give you 0, which is what we wanted. So now our factors, we're going to have y equals 2x plus 1 is one factor. And then we've got 4x squared minus 8x plus 3. All right, so we do need to factorize that. And my 3 decided to come down for the ride, so let's just move that back up. Come on. All right, running out of room, but plus 3. Okay, so I'm just going to use the quadratic formula. Now, I already know that you can have the solution, so I'm going to do that. So using the quadratic formula, x is equal to negative b plus or minus, oh God, it gave me a fright, b squared minus 4ac. I think we'll be right until the end of this video, to a, although I'm running out of room, x equals, now b is negative 8, so it's going to be positive 8, plus or minus b squared is 64, minus 4 times 4 is 16, times 3, 16, 32, 48. Now, hopefully I'm not going to make any mistakes while I'm, why am I putting that around brackets? It doesn't matter. All right, and then 2 times a is 8. Gosh, running out a lot of room. So 64 minus 48, is that 216? Oh, am I going to get? Square root of 16 on 8. All right, so we're going to have to do this in, so 8, square root of 16 is 4, so 8 plus 4 is 12. 12 on 8 simplifies to 3 on 2. And then our other solution is 8 minus 4, so it's going to be a half. All right, so our factors, do I have space over here? Oh, good. Y equals, all right, we got 2x plus 1. And then we've got all right, can I fit them in? 2x minus 3, and the other factor is 2x minus 1. Sorry about squeezing that in. I might highlight it just so people can see it if they're only looking at it. All right, so you do need to probably use your calculator to assist you, but it's good maths, I guess, or good practice in factorizing, especially cubics. All right, I'm going to leave it there. All right, but 2 questions. There's another 2 questions in question 16 if you want to have a go at doing your own. I can't remember whether I set them as questions to do, but question 16, have a go at least doing another one on your own. All right, bye.